In our database system, the tables we have can be very big, and we can have so many different data records or data tuples. And sometimes we may need to select some of the tuples which can meet our requirements or conditions. And then we need to use this selection operation to help us. This selection operation can return all the rows or tuples which satisfy a condition. Condition is some requirements we predefine for some tuples. And we can represent the selection. It can be formally denoted as a sigma with subscript C. The C denotes condition. It's a subscript. And then we have a parenthesis. We have R. R denotes a relation. So it is sigma condition on some relations, right? C is a condition. It can denote some predicates, like some attribute equals to what, or less than what, larger than, or we can even design some more complex conditions by using this and or not in the condition. We will show some examples. And the input is a relation. It is R, right? So the relation will have a schema. And for this operation, after we do the operation on this relation R, we will have a output. So the output will still be a relation, right? You can remember this. And for the output relation, it has the same schema as the input relation. Because this operation do nothing changes to the schema. It only selects the data tuples, right? And let me provide you with a more concrete example. So let's say we have a data table about employees, right? We have 4 attributes. We have SSN, name, department ID, as well as salaries of employees. And we also provide a table for the employees in our database system. We have 3 data records. The first one is about NX. The salary, his salary is 30K. The second one is Bob. His salary is 32K. And the last one is Chris. His salary is 45K, right? These are the data tuples we have in our database systems. And let's assume if you have an application and you plan to find all the employees whose salary is greater than 40K, then how can we find out which employees can meet our requirements? Right. So this is more like a query we plan to execute on this relation, the employees, right? We can do so, or we can represent this as an action by using this selection operation. We can denote this query as the sigma, right? Sigma denotes the selection. We have sigma, then we have a subscript. It is salary larger than 40K, right? This is a condition. This is a condition. And then we have the employees. Employee is a relation, right? We define here, this is an employee relation. And we can find all the employees whose salary is larger than 40K by writing the sigma salary larger than 40K on the employee relation. So by executing this query on the employee table, we can generate the output for this execution, which will be like here on the right hand side. It will still be a relation. It can still be represented as a table. Remember, for this operation, we do nothing changes to the schema, right? So schema will be still the same as the original one, right? The attribute names as well as the value types will remain the same for the output relation, right? However, for the data tuples we have in the output relation, we only have the employees whose salary is larger than 40K, right? Among all the 3 records we have in this employee table, we only have one single employee, Chris. His salary is larger than 40K, right? Then we can add this data table into the output relation. We have Chris as well as salary is 45K, right? Meeting our requirements. This will be returned as a result for this query. So you see, this query do the selection in the rows, right? In the rows of the data tuples, it locate all the employees which can meet our requirements as specified by the condition, right? So this is about selection. And for this selection, the condition is very simple. It has only one single attribute comparison, right? And we can also provide more complex selections. And we can provide it with a more complex selection query. Let's assume we still work on the employee, this relation. And we have a question, we want to find all the employees who are either from department 2 or they have salary which is less than 31K. And how can we do this query and represent it with the relational algebra? So we know that we have to do the selection in the rows, right? We want to find some employee tuples or records in the employee table, which can meet our requirements. Therefore, we know we need to use the selection, right? And we can write down the selection as, right, as this sigma. And then we have some condition, right? Let me write down, change this one. And we know we are working on the employee, this relation, right? And let's see denote some condition. Let me do the subscript first. We have sigma C employees, right? Then the problem will be how to design a condition, right? According to our requirements. We know we want to find all the employees who are either from the department 2, and we'll do the selection of the tuples based on the department ID, right? Or with the salary less than 31K, right? We know we are working on the salary for the second condition, and they are connected by the OR as the connector, right? Then we can rewrite this query by changing the C to some concrete conditions, and we know they are connected by the OR, right? The first condition will be department number equals to 2, right? We can say it is DEPT ID equals to 2, right? Or the salary is less than 31K, right? It will be the condition we have for this question. So the first one will be a department ID equals to 2. And the second one will be salary less than 31K, and they're connected by the OR, right? So then we have two parts. And this is a query we can write by using selection to help us find all the tuples matching our requirements. This is a common way, but sometimes actually we may work on multiple relations at the same time. Therefore, normally I prefer to change this slightly. We can write down this one as employee. This is a relation name, right? Then we have this dot, employee dot department ID. In this way, we can highlight this department ID is from the employee, this table. Okay, this is a relation. We have employee, this is a relation name, followed by a dot, and then followed by some attribute names. In this way, we can specify which attribute from which table or relation we are mentioning. It will be very similar for the scenario here. We can also rewrite this condition as employee dot salary less than 31K, right? This is a query we can write, and by executing the query on this relation table, we can get a new table. Remember, this selection operation, you don't do any changes to the schema, right? So therefore, the schema of the result will remain the same as the input. It will still cover 4 attributes: SSN, name, department ID, and salary. The schema is the same. However, the tuples or data records we have in the table will be slightly different because we are doing selection. Only a subset of instances will be added into the output relation, right? And here we can provide the result we can achieve by executing this query on the input employee this table as shown here. So the schema is still the same. And for the data tuples, we have 2 tuples instead. And we can check one by one. So for the first one, it's about NX. NX, the department ID is 1. However, his salary is less than 31K, right? In other words, this row is valid, it is legal. And then we have another record is about Chris. Chris, his department ID is 2, even though his salary is larger than 31K, right? Since it's a condition for the department ID but is valid, then this one should be maintained in the output table. So by executing the query on this table, we can get the output table as shown on the right hand side. Right? I hope you can follow me about the selection operation. This selection is very useful for the queries we plan to write in the near future. And you will also use this very often for your project, because you need to do some queries in the project to find some data tuples matching your requirements. So it can help you to operate your website on the database systems. This is about projection. Let's come back to the slides and then we can work on the next operation. It's called projection, which can work on the tables by selecting the columns instead. So in database systems, sometimes we may need to select some columns instead. In other words, we don't need to have the very big table. We only need to have that small size table with only a few number of columns instead. If so, we need to use the projection to help us. So the projection is a unary operation. It returns certain columns. Formally, we can represent the projection as a pi with subscript a1 to an, and then we have parentheses, we have r, denotes the relation we are working on. So the pi denotes projection. A1 to an denotes the attributes we plan to get from this relation R, and R is the relation we're working on. Because we'll do this projection by selecting a certain number of columns, by reducing the columns, we may have some duplications created. So remember, in this operation, we will do this duplication elimination automatically. And let's assume we are working on a relation, the R. This R has B1 to Bm as the attributes. We plan to achieve a subset of attributes denoted by the A1 to An, right? And we need to make sure this A1 to An actually exists in the relation. Therefore, to work on this operation, we need to have a condition. The condition is A1 to An is a subset of B1 to Bm. In other words, the attributes we plan to select, they exist in the relation. We cannot select some attributes which don't exist, right? So the A1 to An should exist in the relation. It is a subset of the original attributes of the relation R. This is a condition. Because we'll do the selection of the attributes, we know that the schema will be changed because we only maintain a subset of the attributes in the output, right? So therefore, the schema of this operation in the output will be different. We can represent the output schema as S, A1 to An as attributes. It will be different from the relation we have in the input, right? So this is about the projection operation. We can provide you with an example. Then let's assume we still work on the employee, this is a relation. We have an employee table as shown on the left-hand side. We have 3 data tuples. Here, we want to project the social security number as well as the names. In other words, we plan to get all the social security number and names of all the data records we have in the table. If so, we can represent this operation by its projection, this pi with SSN and name denoting the target attribute we plan to get as the subscript. So pi subscript SSN, comma, name, there are 2 attributes we plan to get, and we are working on the employee, this relation, right? So by executing this query on the input relation, we will get a new relation as shown on the right-hand side, right? We mentioned the schema is different because we now have 2 attributes in the output, SSN and name. They are the target attributes as we required, right? So the schema is changed, right? And we also check this SSN and name that both exist in the original relation. In other words, the condition is valid. And we can get the output as shown here. SSN, name, they are the attributes in the output table and the relation. And let's further check the data tuples we have in the output. Originally, we have 3 tuples. However, this operation, they don't do selection by the rows, right? In other words, all the tuples we have will be maintained in the output relation. We still have 3 tuples in the output table: Alex, Bob, and Chris. We extract the SSN and name in the output table. Right. Okay, so this is about projection. Projection want to get a certain number of columns from the input relation. In this way, if we have more complex queries following this operation, we don't need to work on this larger table anymore. We can directly work on this small size table instead. It can help us shrink the time cost as well as space cost for very complex queries. Right? So this is about projection, another example we can provide. And maybe I can provide you with another example, because we mentioned this operation will do the duplication elimination automatically. Sometimes if we do the projection by shrinking the attributes, we may have some duplications. Okay, let's assume we have a new question. So given the employee relation, we want to project the department ID as well as the salary. How can we do this? So by checking this question first, we know we are doing a projection, right? We don't do selection here. We want to project some attributes from a relation, right? Therefore, we need to use the pi, right? So we can use the pi. We know the pi will have some attributes like A1 to AN, right? As the target attributes we plan to get, and we're working on some relation, right? We may make the A1 to AN as a subscript. So we have the pi A1 to AN on some relation. So we know we are working on the employee relation, right? So we can change this R to employee. And we also want to get 2 attributes, department ID and salary. So we can change this A1 to AN to the DPT ID and salary. Right? We can remove the remaining ones. So we can represent the query we want to get as pi department ID, salary as a subscript, and then we have parentheses, we have employee as a target relation we're working on, right? So we will represent the query as shown here formally: pi department ID, salary, and subscript on the employee table. Let's assume we have a table about employee as shown here. We plan to execute this query on this table. So I make some changes to the table data. Before we have Bob, the salary is different, right? Here we change the Bob salary to 30K as well. And we plan to execute this query on this new table. So by checking this query carefully, we are working on the employee table. We get 2 attributes, department ID and salary. In other words, the SSN and name will be ignored and deleted, right? Formally, we can represent the output table as shown here, right? We have the new table. The schema is different from the input. We only have 2 attributes, right? The schema has been changed. We have 2 attributes, and we check all the data tuples. Before we have 3 tuples. Right now we still have 3 tuples. And then we can check the tuples very carefully, right? Before different tuples, they are all different because the SSN is different, right? The key is different for different tuples. However, if we do the projection of the department ID and the salary by deleting the SSN and name, the output relation will be much smaller in number of attributes. We only have department ID and salary. If we check these rows, we can find a problem, right? Because this row is the same as this one, right? They are both department ID is 1, salary is 30K. Remember, for the projection, we'll do the duplication removal or elimination automatically. In other words, for these rows, we will only keep one record in the output. Therefore, so based on the employee relation, we execute the query on it. We can get an output. However, for the duplicated rows, we may need to delete the duplications. Like we can delete this row instead. And this one will be the final output by executing this query on the employees table, right? In this one, we have no duplications anymore. So remember, this projection will do the duplication removal automatically. So this is very important, especially when you are working on the queries in your project. This is a characteristics for this operation because the data you get will be slightly different from what you imagined, right? They will eliminate the duplications. And we can provide a comparison between the selection versus projection. So we think the relation as a table. In certain sense, they are very similar from each other, right? They are very similar to each other. I say that's similar because they are both do the extraction of some information from tables. Selection is to do the extraction in the rows. Projection is to do the extraction in the columns. They both do the data extractions. However, they are also different, right? So the selection is due by the rows. Projection is by the columns. And for the selection, we are sure in the selection results we have no duplications. In other words, this duplication elimination is not necessary for the selection. However, for the projection, it will be different. By removing some attributes, we may have some duplications, and they will be eliminated automatically by this operation. So they are different. And you may also wonder why we need both. Because for most of the queries we execute in our database systems, the output data will be very small. We only get a small size data as output. In other words, we may need to do the extraction in both the rows and columns. Sometimes the output will be one single attribute. We want to get the value of some attributes. Then we need to do the pruning of both the rows and the columns for us. Therefore, the selection and the projection, they are both necessary. So in the following slides, we will show some examples which are using both selection and projection to help us to design some complex queries for us. Okay, so this is the comparison between a selection and a projection.